Alright, welcome back to another exciting episode of Mr. Richards Teaches Science. Yes, and what have we got in store for you today? That's right, it is Earth's spheres. We're going to learn about Earth's spheres today. Let's just jump right into it. Alright, let's cut with the, okay, I'm going to start this over because that just totally was not good. Alright, and click here, bink, and then back it up. I thought you guys left. You're still there? Oh, okay. Well, we'll get started then, okay? Okay, sorry about that. Okay. So, feedback loops. That's where we're going to start, is with feedback loops. All right. There are two different kinds of feedback loops. There's negative and positive. All right. And so first off, a feedback loop, what it does is you put something into it and then something comes out. That's basically the way it works. And there's two types, like I said, negative and positive. So a negative feedback loop is where a system moves in opposite directions and thus stabilizes the system. For example, a thermostat. All right, if it starts getting too warm in the room, then the thermostat kicks on, and therefore it lowers the temperature. All right. And then if it gets too cold, then the thermostat tells the heating unit to kick on and thus warms the system. All right, and so that's how it stabilizes the system. So it's the system moves in an opposite direction. All right, a positive feedback loop it's of course the opposite of negative, but these drive the systems toward an extreme. And erosion is my example here. And so in erosion, you start off with a little bit. And then it just continues to cycle more and more and more, and the more erosion happens and the worse it gets, and they just compound, and a snowball would be a really good example of a positive, because we use the word snowballing out of control. That's a positive feedback loop. So with a snowball, you start off kind of small and it rolls, and you roll it because you guys have all made snowballs. Well, hopefully if you live like where we live and it snows in weird times. But anyway, so make a snowball, and you start with a little bitty ball, and then you roll it, and it picks up more and more and more snow, and the more snow it picks up, the bigger and bigger it gets, the faster and faster it gets. So that's the way erosion works. So you start off with a little bit of erosion, and it's not that big a deal. But if you allow the erosion to continue happening, it'll soon get out of control. Okay, so feedback loops. Negative, the system moves in the opposite direction. So if it starts getting too hot, then the thermostat will tell the AC unit to kick on, thus lowering the temperature. So it basically the reverse happens. In a positive feedback loop, it continues to grow. Got it? Awesome. Okay, let's see what's next. All right, so we're going to talk about Earth spheres. And so there's four main spheres that scientists have divided the Earth up into. And we do that based on their function. And I get asked all the time, why do we divide stuff up, categorize stuff? And what I tell students is as humans, we like to do that. I mean, organization, some of us like to be organized, and scientists like to be organized. It makes things easier to study, easier to work with. And I like using the analogy, in your drawers at home, where you put your clothes, do you just throw stuff in the drawers? Well, some of you might. But the majority of us, we've got like a drawer for our socks, and a drawer for t-shirts, and a drawer for shorts, and a drawer for jeans or pants. At least I do. And that way I know if I want a pair of socks, and I keep my dress socks separate from my white socks. And so therefore, if I want a pair of shorts, I know which drawer to pull out and know where to find it, instead of having to go look through every single drawer in the dresser. So it just saves time. It just makes life easier. So that's one of the reasons why we divide things up into groups or functions or that kind of stuff. So anyway, the four types of spheres: the geosphere, the biosphere, the atmosphere, and the hydrosphere. Now, if you understand roots and prefixes, then without even knowing what these four things are, we can get an idea of what they're talking about. So we'll look at the root of all these, the sphere part. So a sphere means a circle, all right? Actually, sphere is a three-dimensional circle, all right? like a ball or the earth. And then geo means earth or ground or dirt, rocks, okay? So it'd be the earth sphere or the ground sphere or the rock sphere. So geosphere is talking about the solid part of the earth. All right, bio means life. So that is the life sphere. So when we talk about the biosphere, we're talking about living things. The atmosphere, atmo means above, and so that would be the sphere that's above the surface. So that's all the gases and all that other kind of stuff that goes up there, which we'll talk about here in a minute. And then the hydrosphere, hydro means water, and so water sphere is all how the water moves through the sphere. And someone's knocking at my door, so I'm going to stop the video and I'll be right back with you. All right. That was my son, JJ, wanting me to do something for him. So if you see JJ in the hallway, tell him not to interrupt his dad whenever dad is trying to make a video. All right? That helped me out a lot. Thank you. Okay, so let's get back to the lesson. Earth spheres. So 4 main spheres we're going to study: geosphere, biosphere, atmosphere, and hydrosphere. So let's go ahead and get into this. All right, here we go. So the geosphere is broken up into 4 main layers. All right? They are the crust. The crust is the thin outermost layer of rock on both dry land and underneath the ocean. Okay, so even though there's water on top of it, there's still crust underneath. Okay, remember that's very important. The mantle is a layer of very hot rock, and the mantle is kind of interesting because some of it is like a liquid, but it's not like a liquid like water, like we can easily pour. But it is fluid. It can move. It's just very, very hard for it to move. So it's not like a liquid like we would think of a liquid, but it is fluid. All right. And then there's the core. The outer core is made of liquid metal. Oh, wait a second here. I need to move myself out of the way so you guys can see. There we go. Put myself on Earth. All right. The outer core is liquid metal, and then the inner core is solid metal. All right. And so all this stuff works together to create the world that we have. And without each one of those layers, our world wouldn't exist the way that it is. For example, the core provides a magnetic field that protects us from solar radiation. The mantle, like I said, is fluid, all right, liquid-like, and it allows the crust to move through tectonic plates. All right, and so without all that stuff, our surface of our planet would look completely different than what it does now. Okay, so let's talk about the different layers here. So the crust is about 5 to 70 kilometers thick, just depends on where it is. Where do you guys think it's the thinnest? Okay, yeah. Okay, if you guys all talk at once, I can't hear just one person. Okay, all right, so if you said under the ocean, then yeah, you're right. Yeah, absolutely, it's under the ocean. And the thickest part is on the continents, right? Absolutely. Okay, great. So that's the thinnest part of the Earth is the crust. The mantle is the thickest part, and around 2,900 kilometers thick. That's also where the majority of Earth's energy is stored. All right, and then you have the outer core, which is almost as big as the mantle. It's 2,200 kilometers thick, almost 2,300, and then the inner core, which is 1,200 kilometers thick. And so remember, this is solid, liquid, kind of liquid-like. It's really, really hot. So some part of it's liquid and can still move, but it's still rock. So it's not going to pour like Pepsi. All right. And then crust, which of course is solid. It's this stuff that's hardened. All right. Okay. Moving on. The geosphere continued. So there's different parts. There's the asthenosphere. All right, that's a fun word to say, asthenosphere. It is a softer, hot layer of rock located in the upper part of the mantle. All right, and this is the part that I like to say the plates float on it. All right, because whenever I think about like something moving, I picture a raft or a boat on the water, and the boat's moving around because the water's moving around. We've all floated down, hopefully all of us have floated down rivers, either at a theme park or at an actual river or an ocean, lake, something like that. And so there's this like water. It's not. It's softer rock that can move. So that's on there. And then on top of that is our crust. And
that's solid. And so as this stuff moves underneath, this stuff up here can move, and then our plates move. Now, it's thick, and so it moves really, really slow, to the tune of like 1 centimeter to 8 centimeters a year, depending on which plate it is. That's the asthenosphere. And then there's the theory of plate tectonics. Remember, theory. So the theory of plate tectonics explains stuff that we see, such how the plates move. This explains it. And so convection currents in the asthenosphere move the Earth's plates. And so that's the theory of plate tectonics. And so that brings us to our first talking point, and that is, what are convection currents? Hopefully you've studied them already. If you haven't, maybe somebody around you has, or somebody else wherever you're watching this video has. And so what I want you to do is pause the video, all right, and then go find somebody and talk to them about what are convection currents. So talking point, go talk about what convection currents are. I'll sit here and wait, give you guys like 5 or 10 minutes, and not that long, like a minute or two. Okay, don't pause me for 5 minutes, because I'd get really sad if you left me alone for 5 minutes. Because what am I going to do? I'm in the computer. It's like a box. There's like nothing beyond the sides of the screen. Like there's nothing out there. Like if I move my hands, see, that hand's gone. The other hand's gone. If I move this hand out, it's gone. See, it's gone forever. I have to pull it back. It's back. Okay. All right. I better pause. So, all right. Pause the video. All right. So, did you guys talk about what convection currents are? Okay. So, convection currents is the movement of heat through a liquid. And so what happens is you put a heat source at the bottom, and it heats up the liquid or gas that's in there, and that causes the density to change because the molecules spread apart. And since the density gets less, all right, then that part right there goes to its top because it's less dense than the parts around it. That makes sense. I mean, because that's the way density works. All right, and then as they go away from the heat source, what happens to them? That's right, it cools down, and therefore as it cools down, then it can't come down because new stuff's coming up, so it goes around the outside. And so convection currents is this motion. All right? And we see convection currents in a pot of boiling water, in the earth, around a fire, around a heat source. Okay? I know as a kid, one thing that I would do is I would, when we was camping or building a fire or something like that, I'd make these little like parachute things out of paper and set it on top of the fire and let the convection currents take it off. And they go way up in the air and then around, and then they fall back down somewhere else. And I go pick it up and go put it on there. When I was learning to do this, I wasn't very good at it, and most of the time they caught on fire. But I eventually learned how to keep them from catching on fire and not burning myself. And yeah, it was fun. So, but anyway, okay. So convection currents, might remember that. You might see it again on a test somewhere. So all the talking points are fair game on the test, just so that you know. Very important. Might study those things. All right, let's move on. Okay, the biosphere. The biosphere is the part of the Earth where living things interact with non-living things. All right, so we're living things. We have dogs and cats. They're living things. One of my sons has a lizard, a bearded dragon. It's a living thing. And so the biosphere is where all those living things interact with the non-living things. So like the computer screen, your pencil, your paper, those are non-living. All right, the chair that I'm sitting in, that kind of stuff. All right, so that's the biosphere. All right, let's talk about the atmosphere. Just so you know, on the biosphere, we're going to talk way more about the biosphere in later units. So right now we just need a definition of it, okay? All right, the atmosphere. So the atmosphere is a thin layer of gas that supports and protects the biosphere. So supports the biosphere, what it does is it allows gas exchange to take place basically between producers and consumers. Because remember how we talked about, we'll talk about in the future, that plants and animals depend on each other for the carbon cycle. So we're going to see that connection here in just a few minutes. Not in a few minutes. In the next lesson. Sorry, I apologize about that. Okay. So the atmosphere is a thin layer of gas that supports and protects the biosphere. And one big, huge thing is the ozone layer, and it protects living things from the sun's radiation. Ozone is O3. We breathe O2. It's just oxygen. It's 3 molecules bonded together instead of just 2. And it absorbs radiation from the sun from reaching the Earth. Without the ozone layer, the sun's radiation would destroy DNA in all living organisms, and yeah, there'd be no life on Earth. So it's a pretty important thing. Yeah. All right. And then another important thing is the gases act as insulation, and they protect the Earth from the cold of space. So planets without an atmosphere, they're really, really cold. Planets like Venus with a really, really thick atmosphere are really, really hot. So Mercury, not very much of an atmosphere, kind of cold even though it's close to the sun. Venus, a little bit further away, hottest planet. Earth, perfect temperature for life. Mars, a little bit further away, but it is cold there, really, really cold, compared to the Earth because it doesn't have an atmosphere. And not only that, but the side that's facing the Earth is a lot warmer than the side that's not facing the Earth because there's no atmosphere to keep that heat in. So atmosphere is very, very important. Okay. The hydrosphere. Water, my personal favorite. I love the water. I love taking showers. I like going swimming. I like scuba diving. I like drinking water. It's fun. Well, water that's in Pepsi. Okay, so 97.5% of Earth's water is salt water. So what does that mean? The majority of water on Earth is not usable to us as fresh water. Okay, and you can round that up to 98%. As long as you know that it's like 97, 98% of Earth's water is salt water. And only 2.5% of all the water on Earth is fresh. In other words, it doesn't have salt in it. And only a fourth of that fresh water is liquid. Okay? And the rest is frozen. Right? Which once again means it's not easily usable to humans, all right, or to life forms because it's frozen. And then the majority of the liquid fresh water is underground. And so if we want to get to it, we got to pump it up. All right? Which means it's not really accessible to us. All right? We have to use something you have to use energy to get it up. So very, very little water. Water is one of the scarcest resources on the planet, just simply for the fact that there's tons of it everywhere, but a very, very small portion of that is easily usable for us. All right? So speaking of using water, brings us to our next talking point. What do we use water for? Okay, so here's what we use water for. You guys talk about it. All right, take a few minutes, talk with your friends, talk with people around you, go ask somebody around the library, wherever it is you're watching this, and find out what we use water for. Okay? All right, welcome back. Thank you. All right, hopefully you did pause the video and it didn't just keep going and going and going. If it did, go back and didn't come forward. Anyway, so what do we use water for? So there's some main groups that we use water for. So first off, there's the fun stuff, recreation. So that'd be like, the swimming, scuba diving, skiing, that kind of stuff. And then there's industry, so we use it to make stuff. We use it in agriculture, so that would be like for farming uses. And then we also use it in our households. So we use it to like clean, bathe, drink, cook with, that kind of stuff. So the four main categories is household, industry, agriculture, and recreation. So hopefully you talked about that and you have some ways of how humans use water. Because like I said, talking points, fair game for the test. Okay, let's move on. I think we're almost done. Okay, the water cycle. So the water cycle, what it does is it explains the many routes that water can take through Earth's spheres, because water moves through all of Earth's spheres. So there's precipitation, and that's water moving from the atmosphere to the surface, or from the atmosphere to the geosphere. There's evaporation, where water turns from a liquid to a gas, so that's moving from the geosphere to the atmosphere. And then there's condensation, where gas turns from, or where water turns from a gas to a liquid. All right, and that can happen usually in the atmosphere going back to the geosphere. And so it just cycles through that. And then there's times that water spins in the biosphere because we're made of water, so there's water inside of us. And in almost all living organisms, there's water, or a certain percentage of water. And so that's how the hydrosphere interacts with all the other ones. Okay. That's it. So you've got workbook pages to do. Let's see if I can get those pulled up here. Technology is great. Unit 2 workbook. All right. All right. So let's see. What workbook pages do you guys need to work on? You need to do environmental practice 4. Okay, so you should have already done the rotocycle. All right. So, okay, we got vocabulary. So feedback loop, geosphere, biosphere, atmosphere, hydrosphere, plate tectonics. All right. And then you need to draw and label, draw a picture and label the layers of the geosphere. All right. So just draw a picture of the Earth. All right. Inside of the Earth with all the different layers talked about in the notes. Draw a picture and label the layers of the atmosphere. I would look in your book for that. I'm sure it's in there. And then draw a picture and explain how water moves through the hydrosphere. And so what are you going to draw right here? That's right. You're going to draw the water cycle. Absolutely. Okay. And then number 4, give an example of a feedback loop and then state if it's positive or negative. Now remember, anytime I want you to give an example, you can't use one that we used in class. So it has to be one that you come up with on your own. Okay, so that's it for this lesson. Everybody have a great day, and I will talk to you guys later. All right, bye. If I can figure out how to stop this thing.